So what we've already started studying is a subject called kinematics. Kinematics just describes the way things move. And the kinematic equations are our equations of motion. Now, throughout the year, we're going to be learning a lot of equations in physics. And while these equations should be in your notes, you also need a special place where you collect these equations so you can reference them later and you don't have to flip through your notes. So, at this point, I'd like each of you to make a toolbox that we can put all of our equations into. Now, this toolbox should be in the very back of your notebook, and every time you get a new equation, you put it in your toolbox. Before we start looking at the equations, let's talk about the 5 variables that exist within the kinematic equations. These 5 variables are x, which represents the displacement of our object, v naught, or our initial velocity. It has this little O next to it to let you know that it's the initial velocity. V for final velocity, A for acceleration, and T for time. Now that we know the variables, let's see how we use them. So the kinematic equations really come out of our definitions, the definitions that you guys already know. Our definition for displacement simply says the final position minus the initial position. Now, typically our initial position is just 0. We start at the origin. So our displacement, delta x, is just the value of x when we're moving in the x direction. Now let's take a look at velocity again. As you remember, velocity is speed and direction. So for velocity, it's just our displacement divided by time. So to write it more simply, we just have x, our displacement in the x direction, divided by time. And then rearranging our equation just a little bit gives us x, displacement, is equal to our average velocity times time. That's what this little bar above the v tells us, that it's the average velocity. Now, if our velocity is not changing, then that's the equation that we use, because average velocity is just the velocity. But if our velocity is changing, then the average velocity is equal to 1/2 times the sum of the initial velocity and the final velocity. Now, if we plug this equation in for average velocity, what we end up with is a new equation for calculating our position that is 1/2 times the sum of the initial velocity plus the final velocity times time. So here's the other definition that you're familiar with at this point. It's our definition for acceleration. Now, acceleration is just the change in velocity divided by time. So it's the final velocity minus the initial velocity divided by time. And then when we rearrange this equation, we come up with a more useful equation that says our final velocity is equal to our initial velocity plus acceleration times time. Let's take a look at an example. If our initial velocity is 6 meters per second, our acceleration is 2 meters per second squared, and our time is 8 seconds, we simply plug those values into our equation for final velocity with initial velocity, acceleration, and time. This gives us the equation that our final velocity is equal to 6 meters per second plus 2 meters per second squared times 8 seconds. Now, our order of operations tells us that the first thing we should do is multiply 2 meters per second squared times 8 seconds. This gives us the equation final velocity is equal to 6 meters per second plus 16 meters per second. And finally, we come up with a solution that our final velocity is equal to 22 meters per second. So here are the rest of your tools. We've already seen this equation, final velocity is equal to initial velocity plus acceleration times time. And this one where we solve for displacement equals 1/2 the sum of the initial velocity plus the final velocity times time. And now there are two more for you to learn. Displacement is equal to the initial velocity times time plus 1/2 acceleration times time squared. And final velocity squared is equal to the initial velocity squared plus 2 times acceleration times displacement. Now this chart, equations of kinematics for constant acceleration, is a very valuable chart for you to have, and I recommend that you have this chart in your toolbox. So with these tools that you just learned, you have some new power tools, and you'll learn to do amazing things with these new tools. And we'll get started in class tomorrow.